Hey everyone, welcome to my channel Nihal's Upnote. In this playlist, we are going to learn how to clean your data with Python in a Jupyter Notebook. In this video, we are going to be looking at how to scale and normalize data and what the difference is between the two. Let's get started. The first thing we need to do is load in the libraries we'll be using. Models will use imports numpy as np, then imports pandas as pd here. Okay, then the second step is for min-max scaling. Box cut transformation. Box transformation. Okay, from cpy import states. Okay, now for min-max scaling, we need for min-max scaling. Okay, so from mlx tend dot pre-processing imports min-max scaling. It will generate an error. Okay, so here they say models not found error, no model name mlx10. We need to install this mlx10. Okay. If you are using Jupyter Notebook or Jupyter Lab as me, you may need to install the package within your Jupyter environment. So to do this, are going to add here, stop the kernel, restarts, then okay, and here we are going to install this pip install mlx and execute. So after the installation, you should be able to run the code without encountering the model found error for mlx10. As you see here, so it's successfully installed mlx10. Okay, now let's execute this, and it works. Okay, it's simple, easy to do. Now we are going to need floating models. Okay, import cburn as SNS, then import matplotlib. So first imports cburn as SNS, then imports matplotlib.pplot as plt. Okay. Now let's set seed for reproducibility. Comment here. So np.random seed of 0 executed. So we are finished with the first step, get our environment set up. Scaling vs normalization. What is the difference? One of the reasons that it's easy to get confused between scaling and normalization is because the terms are sometimes used interchangeably. And to make it even more confusing, they are very similar. In both cases, you're transforming the values of numeric variables so that the transformed data points have specific helpful properties. The difference is that in scaling, you're changing the range of your data. While in normalization, you're changing the shape of the distribution of your data. Let's talk a little more in deep about each of these options. Now let's original data equal to mp.random dot exponential of size equal to 100 and min max scale max data between 0 and 1. So here we are going to scaling the data between 0 and 1. To do this, let's name scaled data equal to min-max scaling between this here, words here. Then we need the original data here. Then colons 2, 0. Here we are going to print the original data and the scaled data. Okay, so 0 and here like this. Then we need to plot two together to compare. Big then x equal to plt dot subplots 1 and 2 then fixed size equal to 10 and 3 like this. Then we need to use SNS his plot. Plots, we need the original data. It's here. And the x, it's x of 0. Okay. Then for his plots, we need also the KDA equal to true and legend. Legends equal to false. Okay, x of 0, set title. Yeah, you can just say original data. Here, original data as title. Then we do the same thing for the second plots for the scaled data. Okay, so here we change to scaled data. Okay, x1 not 0. And for here it's our scaled data, not original data. Here also 1. Yeah, then I think, I don't need to use this. Okay. Then, I forget plt.show. Yeah, it's title 1. I think it's okay. It's gonna work. Yeah, okay. Just stop the kernel and restart the kernel here. Sometimes you should just stop and restart the kernel. Okay, as you see, exponential size. Oh yeah, yeah. Or false here. Not like this. And here's the result here. Original here and the scale data here. Here we can notice that the shape of the data doesn't change, but that's instead of ranging from 0 to I think 8 inch, it now ranges from 0 to 1 for scale data. Okay. So what does really mean scaling? So this means that you're transforming your data so that it fits within a specific scale, like 0 to 100 or 0 to 1. You want to scale data when you're using methods based on measures or how far apart data points are, like support vector machines, SVM, or K-nearest neighbors, KNN, or these algorithms. A change of 1 in any numeric features is given the same importance. It's why. Not worry, we are going to see SVM Canon in the next playlist, in the next videos, inshallah. So now let's see how to normalize your data. As you see here, I've already prepared the code here. So you can see in a normalized exponential here, the normalized data. States, box got states, it imports from CP as you see here. It already imports here states from CP. Then we plot both together to compare. So we do a haste plot for the original data and a second haste plot for the normalized data. We are going to execute it now. Okay, so this is the results. Here the original data and here the normalized data. Scaling just changes the range of your data. But as you see here, normalization is more radical transformation. The point of normalization is to change your observations so that can be described as a normal distribution. Let's see what is a normal distribution. Normal distribution, also known as the bell curve. So this is a specific statistical distribution where a really equal observation fall above and below the mean and the median are the same, and there are more observation closer to the mean. The normal distribution is also known as the Gaussian distribution, as you see here, it's a Gaussian distribution. In general, you will normalize your data if you're going to be using a machine learning or statistics techniques that assumes your data is normally distributed. Also, notice that the shape of our data has changed. Before normalizing, it was almost L-shaped, but after normalizing, it looks more like the outline of a bell curve here. Thank you so much for joining me today. If you like this video, don't forget to give us a thumbs up and to subscribe to see more videos. Inshallah, see you in the next video.